All right, last time in class we were working on the Mayan conversions, and that's where we're going to pick up right now. We have just a little bit more to do in this section before we're complete, and we were on example number 6, and when we were taking a look last time, we were actually looking at where we ended up drawing sort of dividers in place value. So you'll notice on number 6 I have 2 dots and I have 3 lines, and I can have dots on top of lines, so the first necessary break would be right here, because I have a line and then I have a shell for 0, and it looks something like this in your book. Other books have had it look a little bit different, and so some version of that's the shell. And then after that shell we see that we have another line, and then we have a line and then a dot, and we would never have within the same place value lines over dots, so we have a place value switch right there as well. That's a little bit low. Let me try that again. Something like that. So above the very first line, we'll just work our way from the top down on the numerical value for each of the placeholders first. So this first one, 2 dots and then 3 lines. Well, each of the line is 5, and then the 2 dots is 2, so this is 17. Of course, this is 0 right here with my shell. And then I have a 5 in this tiny little slip between those 2 green lines, and on the bottom I have a line and a dot, so I've got 6. So again, just like last time, this is the 1's place. This is my 20's place. This is 20 times 18. And this one up here is 20 squared times 18. So 20 squared times 18, and we talked about this last time as well, is actually 7,200. And 20 times 18 is actually 360. So we can take each of these values times the place value they're in, so 17 times 7,200. And I can take 0, technically take 0 times 360. Of course, I don't get anything from that. And then I have 5 times 20. And finally, I have the 6 times 1, or 6 at the end. And if I add all of that together, I end up with 122,506. Okay, so just like we did when we worked with Babylonians in this section last class period, we worked both from their numeration system into ours and from ours back into theirs. So that's what our last examples are going to be, is working from our base system into theirs. This takes a little bit more space on the last example, so we've got to spread out a little bit more. So remember again, my place values are 1, 20, and then I had 360, and then I had 7,200, and last class we also talked about 144,000 as being another option, or one step up from that. So taking a look at 208, of course the largest number here that will still go into 208 is 20. So we set up our division to look a little bit different than normal division. I put the 20 on the outside, I put the 208 underneath, and I say how many times will 20 go into 208, and of course it's 10. 10 times 20 is 200, which is a remainder of 8. And then the next place down after 20 is 1, so I put 8 goes into 1, and it goes in 8 times, and 8 times 1 is 8, so a remainder of 0. So what I actually have is 10 and then 8. So I get a 10 by doing 2 lines, I get an 8 by doing 3 dots, and a line, so 5 and then 6, 7, 8. So this is my Mayan numeral for number 7, for number 208. All right, so let me copy these sort of values here to my other slide, because I'm going to need them again. We have these different place values. Oops. And we've got 58,532 here. So the highest value here that would go into 58,532 is 7,200. So we're going to put 7,200 on the outside. We're going to try that a little bit bigger. 58,532 on the inside. And if you take your calculator and you divide 58,532 by 7,200, you'll get that it goes in 8 times. And then 8 times 7,200 is 57,600. And then if we subtract, that gives me a remainder of 932. Now, no matter how big this is, the next value that I would go to is 360, because it's one value less place value wise, then the 7200. So 360 would be next, and actually 932 does go into 360 does go to 932. It goes in one time. Sorry, not one time, two times. Let me get that right. And then 2 times 360 is 720. And then if we subtract 932 minus 720, I have 212. I take my next place value, which is 20, so 20's place, and if I divide by 20, I get 10. And of course, 10 times 20 is 200, which leaves me a remainder of 12. And after my remainder of 12 here, I would go to the ones place. It would go in 12 times, and I would have a remainder of 0. So let me move this over here to the right-hand side so that we have space to actually write the numeral. So our numeral needs to have a number 8, so that's 3 dots. That line, that's 8. And then it needs to be the number of 2, so that's 2 dots. Then we need a 10, which is 2 lines. And then we need a 12, which is 2 dots and 2 lines. And hopefully as you look at that, you think to yourself, okay, this doesn't really look quite right. It's not what I would have expected. In fact, it looks like I actually only have 3 digits there. And if we were going back and given this number, that's kind of what we would do. We would say, oh, well, let's draw a line between each one of where the line turns into dots. So it'd be very quick and easy to think that this is actually 8 times 360 plus 12 times 20 and 12 times 1. And if I did that, I would actually get that this is 3132. So obviously you can see, I mean, this isn't what our number was. We did everything correctly, but again, the Mayans, just like the Babylonians, have got some problems with their system. They don't have a good way of differentiating when we do not have a place value with dots and we do not have a place value with lines. The dots and lines tend to run together and look like the same place value. So this number 3132 would look exactly the same in Mayan as the number 58,532. And of course, just like we talked about last time, that's not so good, right? If somebody owes you $58,532 and they somehow think that they're only going to pay you $31.32, you're not going to be too happy. So they've got some, issues with their system as well.